Hello, everyone. Welcome to the TAQELAH webinar, and thanks for being here. We thank for the tremendous support you've shown for our meetups. Please do watch the videos for our past meetups in our Facebook group as well as in the YouTube channels. The topic for the day is next generation functional testing using visual AI. So UI testing has grown from the humble background using DOM-based and to the pixel-based testing tools, and now it's leveraging artificial intelligence. And Applitools is a pioneer in visual testing, leveraging the artificial intelligence platform. And Adam is the Applitools is co-founded by Adam Karmi, and he's also the CTO. So he has 15 plus years of experience in technology leadership, research and development, with occupying various positions at IBM, Microsoft, and Intel. So one interesting fact, he's also the organizer of Israeli Selenium Meetup Group. And we are happy to have Adam Karmi with us. And thanks, Adam, for being with us. We are excited to hear from you on the visual testing, especially on the AI platform. And the stage is yours, Adam.
Thank you very much, Praveen. It's great to be here. Hi, everyone. So next generation functional testing using visual AI. So it's not a big secret that many teams struggle with automated functional UI testing, some even to the point where it is completely abandoned despite the fact that the UI is the most important interface of the system. And even teams that experience initial success soon find themselves unable to retain high test coverage as the overhead of maintaining existing tests and analyzing test results increases over time. In this session, I will introduce a new technique for implementing automated functional tests that eliminates most of the downsides of the traditional approach. It is based on visual AI, which is the advanced computer vision technology that powers our visual testing service. And it has been successfully used for years by our R&D team at Applitools and also by hundreds of other teams around the world. And I'm sure that you'll find it very useful as well. And I'll begin the talk by reviewing some of the challenges the teams experience today with the traditional approach to functional test automation. In this talk, I will focus on end-to-end functional UI testing, although the technology itself applies to most other types of testing as well. And when we're talking about end-to-end functional testing, we're talking about testing the functionality of the system through its UI. It's the most widespread form of functional testing. It's the type of testing that you do with tools like Selenium, Ipium, Cypress, Playwright, and dozens of other excellent tools. And a test is basically a sequence of steps where in each step you simulate some user input, navigating, moving the mouse, clicking, typing, and then you validate the output of the page by using assertions. Now, as you all know, end-to-end testing is critically important because even if all the components of your system are working flawlessly, if you don't integrate them together and they don't work well together, you might end up with a suboptimal system that no one would like to use. So as an example, let's look at a very simple test that probably most of the companies in the world need to implement, where we want to make sure that if a user tries to log in to our application without providing the username and password, is introduced with the error messages that indicate that those fields are required. This is how we would simply implement such a test with the Cypress framework. Again, if you're not familiar with Cypress, don't worry. It would look, it's very easy to read, and it would look exactly the same in every other framework. Basically, in line 3, we visit the login page. In line 5, we click the login button. And then in line 8 to 17, we have a bunch of assertions that make sure that there are 2 DOM elements on the page that represent the error messages, and that those error messages have the correct text. And then we just try to log in again by clicking the button just to make sure that it works. So this is how we would say a very simple way to implement a UI test that covers this functionality. But what would happen if another developer on the team or in another team changes the CSS, let's say, of our web application for his own needs to fix something on another part of the application, but accidentally causes our signing button to change. Now it is narrower, it has a green background, and the text is black instead of white, and it's not capitalized as it should be. This is what we would call a visual bug. The reason we call it a visual bug is because the button does not look like we expect it to or we intended it to look like, but the functionality still works. If I try to click it, it will try to log in and I will still see the error messages. However, what will happen if that CSS change would actually change the text of the error message to be white? In this case, the error messages are still there, but they are white with a white background, and the end user cannot see them at all. In this case, we would say that this is a functional bug because since the user cannot see the error messages, the functionality that we're trying to validate doesn't work, right? And the annoying thing is that our test still passes in both situations, when we had a visual bug because it didn't check for that, and we had this functional bug because it didn't test for this specific kind of failure as well. This was just a very, very simple example of a login page, but most applications have screens with hundreds of UI elements. And let's take a look at this example application. How many functional assertions do we need to write in a test just to validate this specific state of the application? I'm not even talking about the images and the graphs, just the DOM elements that we can assert on. So clearly, these are hundreds of lines of test code that a developer needs to write and maintain. And when the UI changes, and as you know, the UI changes a lot, then test will break because they use these locators to locate those elements, and though the structure is now different. And then those same developers that need to write all these tests and add all these assertions now have to stop what they're doing, need to look at the test results and the logs of the system and the tests, and figure out if the test is broken or there's a bug in the application. And if it is the test that's broken, they need to start looking into the tests and fixing them so they can rerun them and see if everything works or there is another failure. And because while they're busy doing that, and usually there are very few people that actually are responsible for doing this type of maintenance, that have the coding skills and are responsible for maintaining tests, they're doing that instead of authoring new tests, and this results with the coverage gap getting bigger and bigger. And what we see is the team spend anytime between 40 and 70% of their time reviewing test results and maintaining tests that they would otherwise could spend on writing a new test and adding coverage. So the reality of automating UI tests, it's very painful. I'm sure that it's not a big surprise to you guys. Every assertion you need to write increases the maintenance overhead, and teams start asking themselves if it's even worth it. Perhaps it's something that is low risk. Perhaps it's better to check it manually. You cannot really automate everything. Coding skills are required to create and maintain tests, which is a huge bottleneck. We see teams where you have a bunch of people that are responsible for automation, and there are hundreds of manual testers, right, that are there to fill the gaps. You cannot assert on non-DOM elements, images, Canvas, CSS graphic, WebGL, to name a few. So again, more coverage gaps. The value that you get out of this automation technique is limited because all you can do is check the system functionality through the UI. You don't test the UI itself, which is, of course, a very important interface. And as we mentioned before, you can only catch expected bugs. If I had 2 assertions in my test, the only thing that I know that when the test passed is that the 2 assertions hold. There could be 1,000 other ways for the page to fail, for the application to fail, and our test will continue to pass, right? All these result with the outcome that you get low test coverage from your automation, and you have to compensate for it with manual regression testing, call it exploratory testing, call it regression testing, whatever, you still have to do it because automation is just not enough. The solution that we propose to this problem and that we found to handle it very effectively is to automate your UI testing with visual AI. And the way that you do it with Applitools is that we provide you with an SDK that you incorporate inside your test code, your existing tests, and it allows you to replace all those traditional assertions with a single line of visual assertion that you will never have to change ever again. What this visual assertion does, in this case, it's eyes check window. It grabs a screenshot of the entire page, not just what's visible on the viewport of the browser or the device, the entire page, uploads it to our server for analysis, where it gets compared with the baseline image that defines the expected appearance of the application in that specific state, in that specific position in the test. Now, if there is any difference, the system will report it. The SDK will throw an exception that will fail your test. And this exception will include a link to our dashboard where you can clearly see what changed. Okay, in this case, we can see that the forgot text is gone, right? Everyone in the team can do it. And all you need to do to maintain the test is just decide if this change is valid or not. If it is a valid change, you simply accept the new screenshot and it becomes a baseline for a subsequent test run. If this is a bug, you reject the checkpoint and report a bug. We have a built-in issue tracking system, and it also integrates with Jira, etc. So it's very, very easy to maintain, and everyone in the team can do it. You don't need to go into the code and change anything. Visual assertions have many advantages over the traditional assertions. First of all, a single line of code, a single assertions give you complete visual and functional coverage for the entire page, literally replacing hundreds of equivalent lines of assertion code. Second, your code does not break when the UI changes. When the UI changes, and it does, all you need to do is go to the dashboard, see the change, and either accept or reject it. No more you need to look at those textual logs and go into the code and start changing, replacing locators or changing the code itself. Another big advantage is that to do this maintenance, all you need to do is to be familiar with the application that you're testing, to either accept or reject differences. You don't need to know how to code. All you need to do is just know the product. And again, it opens up a very big bottleneck because at this point, every tester on the team, even if he doesn't have coding skills, the product team, everyone can participate in the test maintenance process, which opens up, again, a big bottleneck and frees the developers to focus on adding more test coverage and writing new tests. With this type of testing, because it by default validates an entire page, you start finding unexpected issues. Any change that will take place, you will know about it and will never miss it, okay? So unlike the example that we saw before with Cypress, the entire page is validated and any change that would happen there, whether visual or functional, you'll know about it. And another important advantage is that you can actually add these visual assertions to whatever programming language and whatever platform and technology that you're using for testing today. We support over 50 SDKs that basically allow you to do it, so you can get more out of your existing test. You don't have to throw it all away or start from scratch in any way. I'd like to support my claims with some data from the Applitools Visual AI Rockstar Hackathon that we held earlier in the year, where we basically ask a large group of test automation professionals to write a set of UI tests for a buggy web application using the traditional approach and using visual AI. Now, here are some of the results that we found. First of all, the time it took the participants to complete the challenge was almost 6 times faster with visual AI. And for the 10 best participants that completed the challenge, it was almost 8 times faster. In terms of lines of code, it took them 50% the amount of code using visual AI and 70% less code for the winners. In terms of number of locators, and we can consider that as a measure of the amount of maintenance and flakiness of the tests. So it required 80% less locators with visual AI and 95% for the winners. And in terms of the bottom line, what was the level of coverage? Then for the overall participants, they actually covered 95% of the bugs versus only 65% with the traditional approach, and winners actually got the whole 100%. Now, I think these numbers clearly show the advantages of the visual AI approach. But what's even more amazing about them is that first, you can see that there isn't a big difference between the 288 participants that completed the challenge and the 10 best ones. So you don't have to be like the best developer or tester to be able to succeed with visual AI. The second interesting thing is that the participants in the hackathon were test automation experts such as yourselves. These are people with years of experience working with the traditional way. And this was the first time they were introduced to visual AI. Just think how the numbers would look like if they also had a lot of experience with visual AI. To conclude this section, what we see, with the hundreds of teams that are using this approach is that anything that you can do with traditional UI testing today, you can accomplish with visual AI, only that you get on the way a lot more coverage, and it takes a fraction of the effort to author new tests and maintain existing tests. And the things that we see that people are doing in UI tests that you cannot accomplish with visual AI are in most cases an indication that you're doing something at the UI testing level that they shouldn't be doing, that you are better off doing as part of an integration test or an API test, or even at the unit test level. Okay, so now, of course, in order for all of this to work and be reliable, the technology itself has to be very accurate and robust. And although visual AI is not 100% accurate, today we have a single false positive out of 1 million checkpoints, which is very accurate, and we are continuously working on improving that. Visual AI is basically a large collection of computer vision algorithms that are focused in 2 areas. The first area is to be able to compare screenshots just like a human would. And this includes, on one end of the spectrum, being able to completely ignore differences that are invisible to the human eye, certain rendering differences. I will show you a few examples soon. And on the other hand of the spectrum, being able to handle like extremely different images. So think of comparing a screenshot from one device to the same state of the application on another device. Think of a dynamic retail site where the data is dynamic. There are different products. Depending on the current inventory, there's the deal of the day that is different, the discounts that are dynamically added, all these things. So pattern detection and all of that, just like a human tester could look at the page and determine that it's okay, these algorithms do the same. The other area of focus is eliminating repetitive maintenance tasks. So when we see a difference, we cannot tell really if it is a bug or not. The reason is that even people don't agree about that. I see my own developers and product guys argue if the change is good enough for production or they need to change some more, if they like it or not. Similarly, a machine won't be, because of that, a machine won't be able to make the right choice, because there is no right choice for actually. But given the fact that an authoritative person who knows the product has decided that something is okay, we can have algorithms running and applying this same decision everywhere when the change appears, right? So if it appears 100 times in different pages of your application and in different devices, browsers, and operating systems, we can use that initial feedback to apply it everywhere. Another example is if there is a recurring change in your application, a dynamic area, and you don't know the product, so you don't know that you need to ignore it, and it is failing your test, the system will automatically suggest it to you, telling you that there is actually a recurring difference here. Maybe you want to start ignoring it. If the page changed, let's say you added a button somewhere or changed the margins of some elements and everything shifted, Visual AI will identify that and ask you if this is intentional, and if so, do you want it to adjust all those dynamic regions for you? And if you say yes, we cannot decide on our own because it might have been a bug. But if you say yes, we automatically shift all those regions for you and save you the hours it would take you to do it manually. So a lot of things that go a long way in automating maintenance activities. Now, in order to accomplish that, there's a lot of algorithms being written in the last 7 years. Many of them taking multiple approaches. Many of them are rule-based and hand-coded. Many are machine learning based, and some are deep learning as well. So here's an example of the type of differences, the type of a difference that is invisible to the human eye that we have to be able to ignore. In this case, you can see a playlist tab at the bottom, which is white, which has the playlist text appearing there. And you can see the magnified pixels at the center of the screen. As they appear, as they get rendered on when the same device is connected to a different screen, okay? So you can see the result is very, very different. On one rendering, there are pink pixels, and on the other, there are only different shades of blue, okay? Now, if you look at the original playlist tab, you can see that this is completely invisible to us as human beings, right? So you need very sophisticated algorithms to be able to identify that there are so many pixels that are different but are still invisible to the human eye. But on the other hand, not to ignore 2 or 4 pixel difference that can be the difference between a comma and a period, or a plus symbol to a minus symbol, which are very important and very visible, and we must not neglect them. Okay, even if there are just few pixels on a huge page with tens of millions of pixels on it, right? So this is one type of things that we need to overcome. Here you can see an example of comparing a screenshot taken on one device with another device. So it's a Google Nexus 5 versus Google Nexus 4, and you can see that the form factor is different. Because of that, the text spans different number of lines. The images have a different size. But still, the algorithms are smart enough to understand the structure of the page, realize that everything is actually in place, ignore all those issues which are not important, but still show you that the logo moved at the top of the application and let you know that there is a structural change there. When the UI changes, or things shift around, then of course, large portions of the page will be different. So if you know that you made that change, it's very easy to just dismiss it because you actually know that you moved things around. But when you do that, you might miss out of additional changes that hide beneath this shift, okay? So in this case, what will happen is that the system will tell you, hey, I see that a page shift. Would you like to ignore those shifts so you can see other changes? As in this case, you can see that there was actually an additional text change hidden. And by using these tools, you won't miss it, okay? Here's another example of automated maintenance, where in this case, we have 76 differences in our test run that span different devices, browsers, and operating systems. And although it is easy to accept and reject each one of them, going over 76 differences is a bit overwhelming. So what you can do is ask the system to automatically group similar differences. And within seconds, it takes those 76 and turns it into just 2 distinct changes. And then with just 2 clicks, you're done maintaining your tests, right? So it's a very, very helpful set of features that really allow you to scale your tests and without really increasing the amount of maintenance overhead. One of the recent additions to Visual AI is Visual Element Locators, where we use Visual AI not just to validate the outputs, validate the correctness of the page, but actually to drive the test itself. There are cases where you have games, for example, or other challenging UI technologies that you cannot find DOM elements on, and so it's impossible to locate them and then click on them, for example. What you can do with Visual AI with Applitools is basically define a catalog of such images from your test results and name them, and then using the SDK, ask for their location. And you will get back the bounds of where this element appears on the screen, and then you can move the cursor there and click it or do whatever you want with it. Now, this is useful not just for games and let's say difficult technological difficult UI technologies testing-wise. For many teams, even the fact that when the UI changes, they can simply go to the dashboard and recapture the image from the test results, and they're done maintaining instead of having a developer go into the code and fixing the locators there is really a big deal. Okay, so again, the coding skill as a prerequisite is a big bottleneck, and this really helps address it. A very interesting technology that you get with running Visual AI is the fact that you also get root cause analysis. Basically, root cause analysis does not only show you what changed visually, but also tells you what change in the code, what was the change in the code that caused this. So when it comes to web applications, for every screenshot that we take, we also grab the DOM and CSS. So and we have that for the baseline image as well as for the checkpoint image. So when you click a difference on our dashboard, we automatically show you all the CSS, all the DOM and CSS changes that actually caused it. Okay, and this can save a lot of time for developers, especially because in many cases, it's another developer that is causing the change accidentally by trying to change something elsewhere in the product, and it gives you a good hint of what went wrong. There are cases where the bug reproduces 1 in 10 runs or requires special data, so it saves you the time to try and reproduce the bug. And it also empowers the QA engineers to create and report bugs with a lot of data and information that they couldn't have before. The examples that I showed you so far have been around Cypress and web applications, but in fact, we support all programming languages, all types of application, whether web or mobile, native mobile, iOS and Android, just working with screenshots, targeting just about any test automation platform that you can think of, from developer platform to platform for test automation engineers, to manual testers. They're all supported. So even if your organization uses a very diverse tech stack, then every team will find what it needs with Applitools to work with, and any new technology that will come up, we will also support it. By the way, this approach is very, very useful for migration purposes, whether you are rewriting your UI of your application, or if you are migrating from one test environment to the other. If it's based on Visual AI, you have much less code to migrate. Of course, the tool also integrates with all the ecosystem tools, the CI systems, and the source control management systems such as GitHub, GitLab, Bitbucket, and the rest of them, making it very easy and fluent to use for developers as part of the pull request, etc. So the last part of this session is about how you execute your tests. Now, every team, once they have test automation in place, the next thing they want to do is run those tests on the same devices and browsers that their own application users are using to interact with their application. And of course, you want those tests to run fast and be stable and scale as you have more tests to run. One of the huge advantages for writing tests with visual AI is that the fact that you can actually run them, execute them across different devices and browsers using the Applitools ultra-fast grid. Now, the Applitools ultra-fast grid works very differently from traditional grids that you are probably familiar with. In the following way. So with a traditional grid, if you have 1,000 tests and you want to run them on 20 different devices and browsers, you basically need to alter your test framework to run each test 20 times, one on each of these devices. This means that basically instead of running 1,000 tests, you're running 20,000 tests, which means that you have 20 times the amount of time to wait for those results. You need to wait when you have 20 times the amount of test code, test results, and logs to analyze when there is a failure. Every interaction now with the page is an HTTP request to the other side of the world, meaning that the tests are much slower and flakier. And I guess that no one really is happy with this setup. The Applitools ultra-fast grid works in a very different way. The way that it works is when you instruct the SDK to do a visual checkpoint, it actually, instead of grabbing a screenshot, it captures all the resources from the browser at that point. The fonts, the images, the text, the DOM, the CSS, everything the browser needs to present the current state of the page. Then it uploads only the deltas, what has changed since the previous checkpoint or the checkpoints, and indicates the list of devices and browsers that you want to test on. What the ultra-fast grid does then is that within seconds, it spawns up those devices and browsers, injects those resources into them, which actually causes to reproduce the same state of the application on these different devices and browsers, and then take a screenshot and perform a visual test of that screenshot. So the result is that you just run your 1,000 tests once, and at the same time it takes you to run them just once, you get the coverage for those 20,000 tests. Okay, and the wonderful thing is that you don't need to change your test infrastructure or anything to make it work. All you need to do is just provide a configuration that indicates the different devices and browsers that you want to run on. So let's see it in action. Just a second. Okay, so the test that we'll run will be a very simple test. What we'll do is that we will go to wikipedia.com. We will search for the functional testing article. And then we would like to validate this entire page and everything on it. Okay, so that's what we want to do. And the test that we'll run is written in Playwright. Again, if you're not familiar with it, don't worry. It's very similar to Cypress and all the other frameworks. There's some boilerplate code here, but the important thing is that we have the list of browsers and devices that we want to run on. And then in the test, we basically signal to the eyes server that we are starting a test. The application is Wikipedia. The name of the test will be functional testing. We go to the Wikipedia page, as I did manually. We type functional testing inside the search box, and we click the search button. And then we do a visual checkpoint that, as I explained before, will cover the entire page, and it will use the visual grid to render across all these different devices and browsers. And we close the test. So let's run the test and see what happens. Okay, so what we see now is Chrome starting, okay, going to the Wikipedia page, searching for the article and getting there. You can see that we have just one test running, right? This is just a single instance of Chrome, and it is now waiting. The SDK is extracting the resources, uploading the deltas to the visual grid. The ultra-fast grid is basically spawning all those 15 different devices and browsers, injecting those resources into them, capturing the screenshots, and we are done. And it took us exactly 30 seconds to do. Now, if you're using a grid, you can realize how super ridiculously fast this thing is. If we go back to the Applitools dashboard, you can see the test that we just ran immediately now, 15 tests covering all those different devices, browsers, Safari, Chrome, Edge, etc., on different devices and operating systems. And if we look at the checkpoints themselves, you can see the different layouts of the same page on each of these different devices. And each of these checkpoints is compared with the baseline. And if anything would change, anything at all on that page, you'll know about it. It will show up as a difference, right? So we get full coverage for each of these pages. You saw how easy it is to write a test like that, and you also see how fast it can execute using the ultrafast grid. So the ultrafast grid has many advantages as well. First of all, you cover all environments at the speed of running a single local test. It is much more robust, stable, and fast than a traditional grid because you're running the test just once instead of 20 times. The interaction can be local. There are so many devices that you need to keep open for 15 minutes for the entire thing to run, and with all those chances of failure. Because you're using visual AI, you're getting all the functional cover and visual coverage for your checks as we described in the first part of the presentation. Because we are running fewer tests, 1,000 instead of 20,000, you need to spend less time preparing test data, provisioning the environment for the test, consuming users and other assets that you need to run a test. The tests themselves can be simpler. If you have an application, for example, a responsive web application, it might require different tests for different devices and form factors because the UI might appear different. With the visual AI and ultrafast grid approach, you only need to go through the process once in one of the layouts and you get the coverage for all the other ones as well. The solution is extremely secure. The SDK itself resides behind the firewall. It extracts the resources and sends them outside to the ICE server. There is no access required from the outside server into the organization, such as with traditional grids. So you don't need to open up tunnels or open up inbound network access, which compromises the security of the organization. And it is super developer friendly. If you want to use the ultrafast grid, all you need to do is just take your test and provide the list of browsers and devices. You don't need to write any code or change your test infrastructure to be able to do that, to gather the test results, adjust the reporting, etc. So to conclude, the combination of functional UI testing with visual AI and the ultrafast grid can drastically increase the test coverage and start letting you get a lot more out of your automated test by finding unexpected issues. It drastically reduces the time it takes you to create new tests and the time to maintain them because you need to write much less code and the rest of the maintenance can be done by anyone and doesn't require coding skills. You drastically reduce test execution time and test result analysis by using the ultrafast grid and the visual dashboard that we have. With Applitools, you can support any framework that you're using today and will use in the future and will simplify the transition between those technologies. And because the ultrafast grid is so efficient in the way that it works, it also costs us less to operate, which means that you can cut a lot in the cost that it takes you to operate the test lab. So with this, I conclude the session, and I will be happy to answer any question that you may have. Let me go to the chat and see if we have some question there.
Thanks, Adam, for the insightful session, and it was quite interesting as well. We have a couple of questions, and you could see that in the chat. Are you able to see?
Yeah, I got it.
Okay. Thank you.
How are the first, so a question from, okay, I won't say the names, so I won't be embarrassed of misspelling them, but there's a question, how are the first baselines of our expectations set when testing with visual AI? Are they supposed to be included as image files in the test code? So the answer is that the first time when you have a when you run a test and it does not have a baseline, the checkpoint images are automatically set as the baseline. So you don't need to do anything besides writing the visual checkpoints in your code. You run them, they capture the screenshot, and they become the baseline for the subsequent test run. This happens automatically. You can just run twice and you already, in the second run, you have a baseline to compare with. Those tests that don't have a baseline appear as new in the dashboard, so you can see them. You can also configure the system so that the baseline won't be saved automatically. You will see the test results with new baselines, and you will have to go and improve them manually. But actually, no one wants to do that. So like the 99% of our users simply go with the automated approach. They assume that everything has been tested until now and is okay, and from now on they establish it as a baseline and start and continue from that point. Again, it's very easy, nothing special need to be done to get set up. Okay, next question. How are the first baselines of, okay, this is the same one. So the next one. Is there any root cause analysis feature for native mobile app? So today, no, we don't support it. Root cause, the root cause analysis feature is not supported for native mobile. We will add it later on. There is no ETA at the moment, but it does work for any web application. What are the differences between the rule-based versus machine learning versus deep learning-based implementation? So, okay, that's a good question. So each of these, this could be a talk on its own, right? But just to give you like the gist of it. So each of these approaches is a valid approach that has pros and cons. In general, anything that that doesn't involve heuristics and you are smart enough to understand the problem and how to solve it, you are better off writing an algorithm by hand. The reason is that it is the most efficient. It is very clear and understood how it works. It's very easy to debug. It's very easy to test. Like white box, you can see what are the edge cases, and you can see the equivalence classes of how to test it. And that's it. I mean, and it always works. It's not that it works at the 95% accuracy. It works 100% of the time exactly like you wrote it. So whenever this applies to a problem, then you write the algorithm by hand, and that's an amazingly efficient approach. When you are faced with a problem that requires heuristics, then you go for a statistical approach, and there are many machine learning algorithms that can apply there. Basically, you run some experiments, usually pick some features that you want to capture statistics on, and you let a machine learning model to figure out what are the thresholds for those different features and how these thresholds depend on one another in the optimal way. So when you want to improve the algorithm, instead of changing the code, you simply train the model. You add more data that represents the real world, and the machine learning algorithm adjusts these thresholds. You can also add features and remove them, of course, or play with the architecture of the model, but it's a different game. In this case, the upside is that you can solve very difficult problems that you don't necessarily understand how to solve. And second, it's easier on the maintenance side, because instead of constantly changing the algorithm, changing thresholds manually in the code, you have a system that finds the optimal ones for you just by retraining it and retraining. So it's a very good approach, but the downside is that, first of all, it's much more difficult to understand what's going on and debug it, okay? It's more difficult to test it. And also it's not completely accurate, okay? Even if you can expect to get to 96, 95, 97% accuracy in the best case. And you need to compensate for this lack of accuracy with additional algorithms and additional models that will try to figure out and compensate for the cases where it goes wrong, okay? Deep learning is at the other end of the spectrum when it comes to machine learning. What happens there is that some problems are so complex that you don't even know what features to choose. What are the things that you want to collect statistics on? Okay, and what happens with deep learning is basically you can feed it with raw data, and the model itself is big enough to understand what the best features are. Now, on one hand, this is great because it can give you better results in cases where you cannot get them by hand coding or by using classic machine learning models. On the other hand, you don't use it all the time because it also has a lot of disadvantages. It's much slower. It's a complete black box. You don't even know what features the system is doing. Every time you retrain it, you cannot assume anything about how it works. Anything that you tested before does not apply. You have to test it all over again completely. The experiments that the algorithm developers needs to do now take half a day up to a week instead of an hour or a few minutes to run. So it's much more difficult to develop as well. You need to obtain a lot of data to train these big models and write algorithms to clean up the data or to tag it automatically. So it's a very powerful solution that you apply only in the cases where you really, 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 really need it. Okay, so I hope that you were able to follow my answer. But this is where you would use, and again, there is no best approach. It's like universally. There are things that you can only do with deep learning, and there are things that you would be an idiot to apply deep learning to. You can have different tools that would work much better and would be easier to use. Okay, the next question. I've read up.
Adam, yeah. I can help you with the question. I can read it for you.
Yeah, okay.
One of the participants have read that Applitools supports localization testing.
Yeah.
Could you please explain us more on this?
Yes. So localization testing is notoriously difficult because usually the testers are not familiar with the language, with the target language that they need to validate the product with. This means that there could be cut text, there could be typos, there could be plenty of things broken, and even if they look at it, they don't see it because they don't understand it. On the other hand, the language experts don't know the product. So it's really difficult to coordinate the two, and it takes a lot of work to do. And also, when you have a new release, you have to go over the entire application to make sure that nothing broke anywhere that relates to localization. Now, with Applitools, you can very much improve the situation. It gives a very effective solution because once you have baselined the language, as long as there are no differences, you don't need to test it at all. So you can have releases, frequent releases. If no differences are found, you don't need to test. When there are differences, it will immediately point them out to you, and you can just take those few places where there are changes and send a link to the language expert and ask him if things look okay in those areas, right? And then he can just respond there, accept or reject it, right? Or place like notifications or messaging around those areas and collaborate around them. So basically the ability to baseline those languages and let the algorithms let you know when things change saves a huge amount of time and allow you to really release fast. The other area where it helps is that when you're developing a new language, you can use the structural matching that I shown you in the example of the two different devices to basically make sure that the layout and structure of the new page in the new language is the same as that of the original existing page. Okay, let's say you can validate German page or Japanese page according to the English page by structure. And so if things, text would span and and hide another piece of the page or go outside of the page, you will be able to capture that and know it even as the page is developed. Once the thing stabilized and the page is ready, you can baseline it and start like strictly testing regression on it. Yeah, that's it. It can save a huge amount of time. Very effective way to test localization.
Thanks, Adam, for the detailed answer. The next question is, how does Applitools handle dynamic data on images?
Okay, so there are various ways to do that. So first of all, if the dynamic data is should be ignored because it's completely dynamic and you don't care, it could sometimes be an image, sometimes another image, sometimes text. So you can simply add a region on that baseline area, so it will be completely ignored. You can do this manually from the dashboard, and you can also specify it in code through the SDK using selectors, locators, or just by coordinates. We have automated maintenance that allow you to propagate that region to other pages and other devices and browsers automatically using those automated maintenance features that I explained about before. Now, in addition to simply ignoring everything, you can also place layout regions. For example, they would make sure that if you have an image there, any other image would be accepted, but if there will be no image, it will fail. If there is a text or a paragraph there, any other paragraph that has the same size of text, that is aligned properly, has the same distance between the text rows, everything will pass, even though the content can be completely different. But if there will be the paragraph will disappear or the text would misalign or any other structural change to the content, it will fail the test. And there are other aspects for it as well. You can actually define floating regions, which are regions that are allowed to move in a certain area, so it won't fail the test, but still, as long as the element appear elsewhere on the page, it will work. You can ignore displacements, as I shown you in the examples. If there is a constant shift in the page, you can actually instruct the algorithm to ignore shifts and not fail because of that. And there are other more advanced things that you can do, but basically the solution is very suitable for testing highly dynamic pages.
Thanks, Adam. The next question, does a standalone application can be automated using Visual AI?
Yes, so we have several SDKs that work with desktop applications using different technologies. And we also have SDKs that just work with images. So all they need is an image. So if you have, let's say that you have some test automation tool. So just to give an example, we work with Ricentis and we work with UFT, and we work with other vendors that have built integrations with Applitools. But even if you're using something else that is more exotic, then you can actually use that tool to generate screenshots, and then you can pass those screenshots to the Applitools SDK and validate it that way. This way, we have customers, testing all sorts of things like medical equipment and set-top boxes and all of that. So basically, anything that has a UI, you can test with Applitools.
Okay. The next question, how does the Visual AI works for mobile native UI testing? So we have seen some demo for the browser-based. Can you explain about the workflow?
Yeah, so for mobile, it's exactly the same. You will have, for example, an SDK for Appium or SDK for Espresso or SDK for XUI or Calabash or any of these frameworks that work to automate mobile devices. And you will have a checkpoint with exactly the same name, check window or check region. And it will work exactly the same way. You'll just add that and it will do the same. It will scroll and stitch the full page screenshot. We'll upload to a server for validation. When it comes to the ultrafast grid, then today we do support all desktop browsers and all mobile browsers. But at the end of the year, we will also support native iOS applications. For the ultrafast grid, you can test mobile applications today when you have a local simulator or a local real device or a device on on any cloud with any cloud vendor. You can test this way. But if you want to use the ultrafast grid, just like I showed you in the demo, we will support native applications, iOS by the end of the year, and Android native applications early next year.
Okay.
But just to be clear, you can test mobile native applications just like I showed you for web applications today. Okay, exactly like that.
Sure. So the next question, can it be integrated with CI/CD build?
Yes, we have multiple integrations with CI/CD tools such as Jenkins, TeamCity, Bamboo, Azure DevOps, and others. Basically, all these integrations embed the EYES dashboard that I've shown you inside the build report for the CI system. So in that CI system, as you see the build results, you have also the Applitools dashboard embedded, and you see the test results for that build, and you can do everything directly from inside the CI/CD system. Of course, when it comes to the tests themselves, then just by running the test suite, the fact that we fail the tests by throwing an exception means that any way that you're using today to run the tests and collect the test results, it will seamlessly combine with the visual test. These are the same tests, just with visual assertions, and errors and exceptions will include links to the Applitools EYES dashboard. So it will be very easy for you to take the report from your CI system or the custom report that you are generating today and see the visual differences and jump directly to the test results in Applitools, or do the maintenance from within the CI system as well using these integrations. And as I mentioned, we also have the powerful integrations with the source control management systems, GitHub, GitLab, Bitbucket, etc., that are also very powerful and are mainly intended for streamlining the work for developers.
Thanks, Adam. So we have answered all our questions asked. And thanks again, Adam, for your wonderful time. It was indeed an insightful session. And thanks all participants who participated in this meetup. And we have a special announcement. All the participants for this meetup will receive an Amazon gift card from Applitools. Thanks again for your participation. We have your emails. We'll reach out to you for your address. Thank you. Thanks again.
Thank you very much. It's great to be here.